So if we have this, we have the hydroxide ion concentration, the square root of the Kb times the NH3 concentration. Concentration is like 1.8 times 10 to the negative 6. Times the 15, and then we will square root. So we get the hydroxide ion concentration to be 1.6. Yep. Times 10 to the negative second. Confused on one of my things like that. Like, is that a decimal point? 1.6 times 10 to the negative second. That equals the hydroxide ion concentration. They want the POH. So what do we need to do on that? How would you do it? Hayden, what would you find first? We have the hydroxide ion concentration. What's the easiest thing to find?
POH.
POH, right? We could take this and take 1 times 10 to the negative 14 divided by this, but plus we get to use these buttons that we haven't been able to use, you know, most of our lives, right? We take the negative log of that. That is the POH. Real quick question, is this acidic or basic with a POH of 1.78? That's something you can play mind tricks on yourself all day long, right? It takes an extra second of processing time probably to sit there and go, okay, this is a POH. POH less than 7, right? Or if you don't like those type of mind games, you can sit there and always say, okay, this is the POH. Like using the POH. I like using the pH better. And we get 12.22. This is a problem just like it, so that would be a good practice for you there. Tell you the truth, I think that that's enough for today. We will hit the topic of polyprotic acids tomorrow. Here are the KAs. Now, just to give you an idea of what might be easiest if we look at just this part today, and then tomorrow we do the math. So if we take a look here, polyprotic acids basically mean we have multiple hydrogens. So if we have 3 hydrogens, we know we could lose 1 hydrogen. Now, phosphoric acid isn't even a strong acid for that first hydrogen. So the Ka for that is 7.5 times 10 to the negative third. So if you wanted to find the pH and you knew the concentration of this acid, you would have to do the stuff we did to find out how many hydrogen ions actually came off. Well then, since we made some of this, right, some more hydrogens could come off of that. Is that very likely? It's a lot less likely than this, right? And if you did that, if some did come off, then the last hydrogen could also come off. But you can see that that is very, very, very unlikely. This is way, way, way less than 1. In reality, the concentration or the pH based on the concentration of hydrogen ions for the dissociation of phosphoric acid, it's probably going to be all based on how many come off of that first one. And why would this be different for sulfuric acid? I'll give you a hint. If we look down here, sulfuric acid right here. What type of acid is sulfuric acid? Strong. That's why this is much greater than 1. That means that immediately when sulfuric acid is in there, it loses that first hydrogen. It completely dissociates. So already, whatever the concentration of this acid is, that's your hydrogen ion concentration. The second one, well, I mean, in reality, it's actually, you know, more likely than the first from the H3PO4. But the second one, it could affect the pH depending on your concentration. So just keep that in mind. And that's basically what we'll be looking at tomorrow. I'll do one. Probably tomorrow will be a decently, this will actually probably take about maybe 20 minutes to do, right? 15, 20 minutes to do. Because we are taking it through all of the dissociations. And then I'll let you deal with sulfuric acid. Obviously, 1 molar ain't gonna matter. You're gonna get to the big thing with the pH. But if you go less concentration than 1 molar, and it may actually be even, it may be like if you go a half molar, it may still be a factor. I don't know how that type of stuff memorized. But if you have a lower concentration of H2SO4, you will have to take into account the second hydrogen ionization. And I think that with that, you may actually have to do the quadratic formula. Look, yep, quadratic formula. So then we'll do that one. I'll let you guys do that one for practice. Cool, cool. Any questions? So my version is coming along quite nicely. Unfortunately, I have another 2.5 hours to clean it up. And it will add on the Henderson-Hasselbalch buffer solutions and stuff like that. That I don't know. Maybe this teacher has a supplemental material too, and I just couldn't get a hold of it. But it'll have that stuff added onto it. What this is doing though, and I know that this might be frustrating for some of you guys, is that it's hindering my ability to get things graded as much. So hopefully by I would say Monday, I should be caught up on grading, hopefully. Any questions today? All right. Have a great day, guys. Take care.